For topic 3, we're going to talk about the equations for, let me go ahead and put it here in case you forget what section you're in, for a parabola. So we do have kind of two situations here. We know the equations that we dealt with before, quadratic equation, standard form, vertex form. Here it's going to be a little bit different. And there is a derivation in your book, okay? I didn't feel that it was necessarily the best use of time, especially this close to the end of the semester. I didn't want to overwhelm you with like tons and tons of extra information. The derivation is kind of cool. You use the distance formula and you do some squaring of things, and it's just kind of like fun but messy algebra. So again, I didn't feel it was necessary to necessarily go through it. You can look for it in your book if you're really just desperate for that knowledge. We do have situations where we have an equation where there's no transformation. So kind of go back to 171 again. At some point, I want to say it was in your chapter 3, you talk about transformations of equations. So you talk about horizontal and vertical shifts. You talk about horizontal and vertical stretches or compressions, reflections about the X or Y axis, things like that. Okay. We have just sort of like the basic, we'll call it, it's not really the parent function, but it's like that same idea as the parent functions that we had back in 171. And then we have the idea of, hey, there's also transformations, okay? So the first equation I'm going to show you is no transformations. And then the second one is what we would see when we have those transformations, okay? So first of all, we're going to look at a parabola with a vertex at HK, okay? So that would indicate that we do have transformations. But we're also going to have a vertical axis of symmetry. So what in the world does that mean? Well, remember earlier I said when you have a parabola, you have this like invisible line that goes through the vertex. And that invisible line is something where if you folded the parabola about that invisible line, the two sides would meet. That's where you show your symmetry. So it's quite literally the axis of symmetry. So if you have a parabola that opens up, you have a vertical axis of symmetry, whether the parabola opens up or opens down. But if it opens up or down, you're going to have a vertical axis of symmetry. So the parabola is oriented in a vertical fashion, we'll say. So it opens up or down. Okay. So that's what we mean by vertical axis of symmetry. The axis of symmetry is just a line. In this case, it would be a vertical line. Okay. Now, in the event that you have absolutely no transformations, the generic form of a parabola would be x squared equals 4 times a times y. And I think this is going to do that weird bouncy thing. Remember how that used to happen a long time ago? I copied this table from another worksheet and somehow it makes things bounce. I don't know why. But anyway, if you have just the generic form of a parabola that has a vertical orientation, meaning it has a vertical axis of symmetry, that would be x squared equals 4ay. Now, don't get too hung up about that, okay? So let's come over here and just sort of think about it. If we had x squared equals 4 times some value a, okay, and we know that value of a, remember it's the distance from the vertex to the focus or from the vertex to the directrix, that's what a is. So we have x squared equals 4 times a times y. When we were in 171, we were used to seeing these equations for parabolas that open up or down in the form y equals something. Well, I could take this equation right here and I could divide both sides by 4a. 4 and a are just numbers, right? So I could say, well, y equals x squared over 4a. This looks like what we're used to seeing. We're just not writing it in that format. We're writing it in this new trigonometric format where we can pull some new information from it, okay? Now, in the event that you do have transformations, the equation is going to look a little bit different. So with transformations, you would have something like x minus h quantity squared equals 4 times that value a, and then times y minus k quantity squared. Okay? Now, depending on what a is, if a is positive, this is going to be a parabola that opens up. If a is negative, this would be a parabola that opens down. Okay? The vertex is whatever you subtract from h and whatever you subtract from h. The vertex is whatever you subtract from x, h, and whatever you subtract from y, k. Be very, very careful with your signs. Remember that if we were to have something like x plus h, squared equals 4 times a times y plus k, that would tell me that my vertex is negative h, negative k. So remember, it's always what you're subtracting from x or what you're subtracting from y. So be mindful of your signs, okay? Now, the focus we can pretty easily find. So if you have a parabola that's opening up or down, you're going to have this vertical axis of symmetry, remember? So you have this vertically oriented parabola, okay? We know that we have a vertex at the highest or lowest point, and then a distance of a units away from the vertex inside the parabola is going to be your focus. So to get to your focus from your vertex, you're adding or subtracting some value, and the value that you're adding or subtracting is a. So your vertex is going to be whatever your h value is. So the x coordinate of your vertex doesn't change. The y coordinate of your vertex does. That's going to take you up or down into the parabola to get to that focus point. Okay. Now the directrix, remember, is just a line. Okay. The directrix is a fixed line that is outside of your parabola a units away from your vertex. Okay. So how would we get there? Well, if we have a parabola that's opening up or a parabola that's opening down, just go a units away from your vertex outside of the parabola. So we're right here at our vertex, okay? The x value is going to stay the same. We want to figure out what this y value is, okay? So we're going to focus on the y coordinate of the vertex, and we're going to add, or in this case, subtract whatever a is. Okay, so if a is positive, we just subtract regular a. If a is negative, we end up kind of secretly adding a. But all you have to do is take the y coordinate of your vertex, okay, and then subtract the a value that you find from your equation, and your directrix is going to be the equation y equals something, okay? Now it is a line, so we do write it as a line, so y equals something, okay? And then the last thing that we're going to look at is the axis of symmetry. And the axis of symmetry is going to be the x. Why does it do that? The x coordinate. Good Lord. We're going to do this differently. So the axis of symmetry is the x coordinate of the vertex. Okay, now remember, this is when you have a vertical axis of symmetry. Okay, so you have a parabola that's opening up or down. Okay, now in this next table, we're going to flip things on you a little bit. In this table, we have a parabola that has a horizontal axis of symmetry. Okay, so what that means is that you're going to have a parabola that opens left or right. So this parabola opens left. It's going to have a horizontal axis of symmetry. You could also have a parabola that opens to the right. It has a horizontal axis of symmetry. So this is going to be a parabola that is horizontally oriented. I don't know if that's a real phrase, but we're going to make it a real phrase, okay? So we have two equations. So we have kind of like the generic equation, which don't think of it as a parent function because this is definitely not a function, but it kind of acts the same way as a parent function. So we would talk about like a parabola would just be y equals x squared. That was the parent function back in 171. A line was just y equal x, okay? So sort of like the most generic form of that equation where there were no transformations taking place. Well, this is the generic form of a parabola that is horizontally oriented, okay, assuming there's no kind of transformation. So we would have y squared this time equals 4 times some value a, and remember a is the distance from the vertex to the focus, and it's the same distance from the vertex to the directrix, okay? Now, if we did have transformations, the equation is going to look a little bit different. We're going to have y minus k. Please remember the k constant goes with y and the h constant goes with x. So we would have y minus k quantity squared equals 4a times x minus h. Okay? So be really, really careful with understanding that y and k go together, x and h go together. Okay? Now, in this case, you're going to have a parabola that opens to the right or opens to the left. So if A is positive, so in this case, let me get a different color. We would have A is positive, our parabola is going to open to the right. And if A is negative, our parabola is going to open to the left. Okay, now the vertex doesn't change. It's still going to be whatever we subtract from x comma, whatever we subtract from K. Shoot, the vertex, I'm going to start that one over. The vertex is whatever we subtract from X, comma, whatever we subtract from Y. So for the vertex, it might be helpful. Let me write it here. For the vertex, it's going to be number we subtract from X, comma, the number we subtract from Y. Okay, so be really careful about where your X and your Y are and where your H and your K are. Okay, so be really careful with that. But you're still just going to get whatever you subtract from X, comma, whatever you subtract from Y. Got it that time. Now, let's think about the focus here. So remember, we have a vertex, which is the highest or lowest point on a parabola that opens up or down. Well, if we have a parabola that opens left or right, it's the point that's to the far left or to the far right, okay? Now remember, the focus is inside the parabola. So from this first parabola that opens to the left, if I want to figure out what my focus is, I need to figure out some distance from my x coordinate on my vertex. Same thing over here for the parabola that opens to the right. To figure out what my focus is, I need to figure out some distance that changes from my x coordinates. So what we do is we have to figure out what A is first. So we have to figure out this value for A in this equation here, or this one depending. We have to figure out what A is, and then we take the x coordinate of the vertex and we just add A to that, and that'll give us the point that is our focus. Now, similarly, if I want to find my directrix, remember, it's going to be outside the parabola, A units away from your vertex, okay? What we would do is we would take whatever the x coordinate is of our vertex, and we would subtract A. So to get your focus, you add A, either to your x or your y coordinate, depending. And then to get your directrix, you subtract A from whatever coordinate you need to look at. In this case, we're getting a horizontal orientation. So that means our directrix is going to be vertical, which is going to be some x equals equation. Okay. And then for the axis of symmetry, we get y equals k, which remember, this is going to be because we have a vertex that's like going to be on a horizontal axis of symmetry. We need to really look at the y coordinate. So this is the y coordinate of the vertex. So be really, really careful. Things kind of flip-flop depending on if you have a parabola that opens up or down versus a parabola that opens left or right. Okay, let's go ahead and look at least, we're going to look at two examples, kind of four, but really two. Okay, so example one, we're going to do some grunt work. Okay, so example one says state the vertex, the focus, the directrix, and the axis of symmetry. I also need to add find A. Okay, so we have these two equations. We're going to go through them step by step. We're going to find A, we're going to find the vertex, we're going to find the focus, we're going to find the directrix. We are also, I believe, at the very bottom, yes, going to find the axis of symmetry. And then in the next example, we're graphing them. So it's kind of four separate pieces, but part A, for example one, goes with part A for example two. Okay, so we have x squared equals negative 8y. So we don't have transformations here. If it's helpful to kind of think of this in terms of transformations, that's okay. That way you just kind of have to remember one set of facts. So this would be the same thing as x minus 0 quantity squared equals negative 8 times y minus 0. So we would say here that h is 0, k is 0. So we can go ahead and say, hey, our vertex is going to be the origin here. Okay. Now, next I do want to focus on, I shouldn't say focus, I want to look at finding A. Okay. So we need to rewrite this as x squared equals 4 times A times y. Okay. So how can we rewrite this right here where it's some multiplication where we would end up getting negative 8, but we have two values, 4 and then some value for A. So we can do this a couple of ways. Let me plug my computer in. Okay, so we know this value right here that I'm going to highlight in blue has to equal this other value that I've highlighted in blue. Okay, so what we can say is that, hey, we know that 4A must equal negative 8. Okay, well, I can just take this value and solve it for A. So I would divide both sides by 4, and I would say, hey, A has to be -2. Okay? Well, that kind of makes sense because now if I take -2 and I multiply it by 4, I get that desired -8. Okay? So we can rewrite this whole thing if we want to as x squared equals 4 times -2 times y. Okay, it's the same thing. All right, we've sort of unsimplified that -8. We've written it as two factors, one of which is a, one of which is the 4 that's just kind of a generic part of the equation. Okay. So we now know that a is -2. We also have an x equals situation. And if you go back up to these tables right here, when we had x equals, we knew we were dealing with a parabola that was vertically oriented. So that means it opens either up or down. It has a vertical axis of symmetry. So when we go back down here, we can say, hey, this -2 tells me something. It's going to tell me which direction I open. And this x squared is part of that. Since I have x squared equals, that tells me I'm opening up or down. And this right here tells me I'm going to open down. And I know I'm going to open down because A is negative. Okay. Now we already determined our vertex was the origin. Okay. So right now, let's just kind of sketch in our heads what we think is happening. Okay. We have some parabola. It's going through the origin. That's the vertex, and it's opening down. So we have something kind of like this going on. Okay, now we need to find the focus. So we know when a parabola is opening down, the focus is going to be below the vertex because the focus is always going to be like inside the curve. Okay, so we're going to have a focus. I'm just eyeballing it. We're going to say it's here. Okay, so how would I go from here, 0, 0, to here? Well, my x value isn't changing. What is changing is my y value. Okay, so what I want to do here, okay, for the focus, you have to remember we leave the x alone. Okay, we have to play around with our y. So x is still going to be that same value here. So that was technically h if you remember. And then we want to take the k value, which is whatever's subtracted from y, and we want to add a. So h is 0. Okay. K was 0. And then we need to add a. So we're going to go plus -2. So let's simplify that, kind of pretty it up a little bit. 0 is just 0, but then what is 0 plus -2? Well, that's just 0 minus 2, or -2. So my focus is the point 0, -2. Okay? Now the directrix. We know the directrix is going to be this distance A from the vertex, which we know is really 2. All right, let me move my 0, 0 here. I'm going to squish it down a little bit. There we go. So we know we're going to have some directrix doing this. Okay? Well, how in the tarnation do we get to that point? Okay, so we have to understand that we're looking kind of for this point right here. Okay, that's going to give us an idea of what our directrix is going to go through. So once we figure out kind of what that ordered pair is, we can then write our directrix as an equation of a line. Okay, so how would I get to this point right here? Well, my x value isn't changing, but my y value is. So the official formula here is h, comma, and then we take k and we subtract a. So that's just the ordered pair that the directrix is going to go through. I'll show you the actual equation of the line next. Okay, so h is just 0, k was 0, but now we want to subtract a. So we're going to subtract -2, which gives me 0, 2. So this ordered pair here is 0, 2. But remember, the directrix is a fixed line. So we need to write this as the equation of a line. And we're definitely dealing with a horizontal situation right here. Okay. Horizontal lines are always of the form y equals something. So the equation is going to be y equals k minus a, which would be y equals 2. And that is definitely the equation of our directrix here. Okay. And then finally, let me see if I can squeeze this all in one screen. Barely. Okay, so we need to find the axis of symmetry. So remember, the axis of symmetry is a line that goes either vertical or horizontal, depending on which way your parabola opens, but it goes through your vertex. If you have a parabola that opens up or down, the axis of symmetry is going to be a vertical line that goes through the vertex, okay? So in this case, we're just going to get x equals, vertical lines are x equals something, and it's going to be x equals h. H being the x coordinate from our vertex. So we would say x equals 0 is our axis of symmetry. So let's highlight some really, really important points. We found A, we found our vertex, we found our focus, we found y equals 2 being our directrix and x equals 0 being our axis of symmetry. Okay, now the next example says to graph these and then talk about this extra thing. Remember the lattice rectum? The lattice rectum is the line that goes like through here. We're going to find points that represent that. So I say let's go ahead and hold off on part B right now. Let's do part A of the next example. Okay. So the next example says graph the parabolas from example 1, labeling all points. Also find 2 points that define the lattice rectum. Okay, so let's remind ourselves of a couple of things here. So we did all the grunt work. We know that A, do I have, yeah. We know that A is equal to -2. We know the vertex is 0, 0. We know the directrix is y equals 2, and we know the axis of symmetry was x equals 0. We know that so far. So let's go ahead and plot that, and then we're going to figure out some points that represent that lattice rectum. Okay? Now, really quickly before we get into that, remember from way up here, this, let me get the bright pink. This right here was the lattice rectum, that line segment that goes from this point right here to this point right here. And I told you the distance from this point to this point is the absolute value of 4 times whatever A is. Okay? So keep that in mind as we go down here. Okay? So we know the focal length, or not the focal length, but the length of the lattice rectum is the absolute value of 4A. Let me switch back to the darker pink. That one's a little jarring. Okay? So we want the absolute value of 4 times -2, which is the absolute value of -8, which is 8. So the distance from one point on one side of the parabola to the other point on the other side of the parabola through the focus has to be 8 units apart. Okay, so keep that in mind. All right, so let's do some stuff here. We want to go ahead and plot the vertex. That's this point right here. Okay, we know we have, oh, I forgot to put our focus. All right, the focus was 0, -2, so we can go down here. That's our focus. We know the directrix was y equals 2, so that's this line right here. All right. What else do we have? We know this is 2 units, this is 2 units. So we can go ahead and kind of start thinking about this idea of a lattice rectum. So let's consider this. We're basically looking for new x values, okay? So the first point and then the second point, okay? So we know that the focus is here. The y values aren't going to change. We're trying to figure out how far out this curve is going to go. Like, where is this curve going to go? How far out are these 2 points here and here, okay? So what we can do is we can say, okay, we know that the length, oh shoot, I didn't realize it was in the, we know the length is the absolute value of 4A. Half of that would be 2A. So we basically want to take whatever this is, so 0 plus 2A, comma, -2. We want to take 0 minus 2A, comma, -2, and that's going to give us those 2 ordered pairs, okay? So what was A? A was -2, so we're going to get 0 plus 2 times -2, comma, -2. So that's going to be 0, 2 times -2 is -4. So it's going to be 0 minus 4, which is -4, comma, -2. And then this one right here is going to be 0 minus 2 times -2, comma, -2. Well, 0, 0. And the -2 times -2 is 4. And then we get -2. So we want to plot these points here and here, and that helps us build our parabola. So our parabola is going to do this. Pretend it's perfect. Okay, so this right here, that's what we're talking about with the lattice rectum. All right, this distance from here to here. Okay, so that's the graphing of a parabola. It's a bit more formal than what we did back in 171. Again, in 171 we focused on x-intercepts, y-intercepts, and the vertex. Here we're focusing on the vertex, the focus, the directrix, the latus rectum, the points that give us the latus rectum. So it's kind of a different situation here. I think it's super fun. I hope you don't hate it. I hope I've explained it well. Let's mosey on back to example one and let's start this process over. But this time we're going to look at x minus 1 quantity squared equals 2 times y plus 2. Okay, so the first thing we want to do is find a. So remember, kind of the generic form is x minus h quantity squared equals 4 times a times y minus k. Okay, so we've got to figure out what a is. Now we know like the coefficient of the y component here has to equal 4a. So if I take this right here and this right here, they have to be the same thing. So we can set them equal to each other. We can say, okay, 4a has to equal 2. So what is a? Well, I would divide both sides by 4, and I would just get a is 2 over 4 or a half. So we know that a is equal to a half. Okay, and that should kind of make sense. All right, if I take 4 and I multiply it by a half, what do I get? Well, I get 2. Okay, now we also want to just take a moment and think about, does this open up? Does it open down? Does it open to the left? Does it open to the right? If you have x squared in some capacity, x squared by itself or x plus or minus something quantity squared, you're dealing with a parabola that is vertically oriented. Okay, so we're dealing with this right here, which is a parabola that is going to open up or open down. And this right here tells me that we're going to open up. Okay, so just as kind of a general sketch, what do we have so far? Well, we have a parabola that we know is going to open up, but let's find our vertex before we start to sketch anything. Okay, now the vertex, remember, is going to be HK. H is what we subtract from X, K is what we subtract from Y. So what are we subtracting from X? Well, we're subtracting 1. What are we subtracting from Y? Since we have Y plus 2, that would be the same thing as y minus negative 2. So what are we subtracting from y? We're subtracting negative 2. So our vertex would be 1, negative 2. So let's say that's our vertex, okay? So what's going on? We have to now find the focus, which we know is going to live inside the parabola, and the directrix, which lives outside the parabola. So we know we're opening up. All right, we're doing something like this. So we need to find our lattice, not our lattice rectum, our focus and our directrix. That's a mouthful. Okay, so let's think about this. We know the focus is going to be up here somewhere. We know the directrix is going to be down here somewhere. We don't know exactly where, but we know we're going to be the same distance from the vertex. One is going to be above, one is going to be below in this case. Okay, so let's think about this. We know that the x coordinate isn't going to change. It's going to stay exactly the same. Okay. What is going to change is the y coordinate. Okay. So in this case, the h is going to stay the same. And then the k value from our vertex, we're going to add a to that. So h is going to stay the same. And then k is negative 2, and we want to add 1/2 to that. So what is that going to give us? Well, that's going to give me 1, comma, negative 1.5. More officially, you'd see it as negative 3/2, but you can use the negative 1.5 if that helps. So let's think about what that's going to look like. That's going to put me down here. It's pretty close to the vertex, okay? So that's my focus, 1, comma, negative 1.5. Now the directrix, okay? The directrix is an ordered, it's not an ordered pair, it's a line, but sometimes it can be helpful to find the ordered pair that represents that, okay? This is actually going to be a good bit closer. It's going to be like here, okay? So what we can do is if we can figure out what this ordered pair is right here for the directrix, we can figure out the equation of that line. So kind of think of it like this. Hey, the h is going to stay the same. The h value, the x coordinate from the vertex isn't going to change. But we do need to take whatever the k value is and subtract a. So we could say, okay, h is going to stay a 1, but k, which is ordinarily negative 2, we're going to subtract another 1/2 from that. So the directrix is going to go through the point 1, negative 2.5. So what is the equation for the directrix? Well, it's going to be a horizontal line that goes through this point. So horizontal line through this point. So we would say it is y equals negative 2.5. So let's draw our directrix. It would be like this. Okay. And then finally, the axis of symmetry. Let me see if I can squeeze this all. There we go. The axis of symmetry, if you are if you are a vertically oriented parabola, which we definitely are here, you're going to have some vertical line that runs right through your vertex. So this is going to be something in the form of x equals h, where h is the value subtracted from x in the original equation. So the axis of symmetry here is going to be x equals 1. Okay, so let's highlight some stuff. We've got our A value, we've got our vertex, focus, directrix, and axis of symmetry. Okay, so let's graph. This one's going to be really hard to graph. I chose a horrible piece of like grid paper. So this one's going to be especially hard to graph. I do apologize in advance for that, but I'd already printed these when I realized like how bad it was and I didn't want to waste paper. Okay, so we had that A was equal to 1/2. The vertex was equal to 1, -2. The focus was 1, comma, -1.5. The directrix was at y equals -2.5. Okay, so let's see what we've got here. We have a vertex at 1, -2, so that's going to be right about there. We have a directrix right here, or a focus right here, and a directrix like right here. Okay, you see what I mean when I tell you I picked terrible grid paper? I'm sorry about that. Okay, so let's talk latus rectum. So we know the distance from one side of the parabola all the way across to the other side of the parabola through the focus has to be a distance of 4a. So 4a, so that's going to be 4 times 1/2, because a is 1/2, so it's going to be a distance of 2. So the 2 points on opposite sides of the parabola through the focus are going to be 2 units apart, okay? So let's figure out what those units are going to look like, okay? Well, we know that this is the focus. Okay, I'm just going to do this gentle dotted line so we can like really see what the focus is. So we need to make sure we understand that the y coordinate isn't changing, the x coordinate is. Okay, so we're going to take the original x coordinate, which is 1. We're going to add 2 times a, because half of this, whoops, half equals 2a. And then we're going to keep the y coordinate exactly the same, which was -1.5. And then we're going to take the x coordinate and subtract 2a, and then keep the y coordinate exactly the same. All right, so what is 2 times a? Well, a is 1/2. 2 times a is 1. So we're going to get 1 plus 1, comma, -1.5, which is going to be 2, comma, -1.5. And then we're going to get 1 minus 2 times a. Well, a is still 1/2. 2 times 1/2 is 1. So we're going to get 1 minus 1, comma, 1.5. So we're going to get 0, comma, -1.5. So let's plot those points. So 2, 1.5, 0, 1.5. Our parabola is doing this. Shoot, I just drew it at the wrong spot. No, I didn't. I had it right. Dadgummit. So the vertex is this one. We're going to go up and up. And remember, this is our directrix down here. Let's erase some of our guide points. We have an axis of symmetry right here. Ta-da! Okay, so you've got your vertex, your directrix, your focus, the 2 points that give us the endpoints on the latus rectum, and the axis of symmetry. Okay, so we did a ton in this video. Sorry, it was a little lengthy, a bit long-winded, but it's really important that you understand how to do all of these pieces. Find A, find the vertex, find the focus, find the directrix, find the axis of symmetry, and then use those points to graph. It's also helpful if you understand the latus rectum, because that helps us get like kind of the width correct. Okay, so in the next video, we're going to look at, hey, Can we create the equation if we're one, given a graph, or two, just given some important points on a parabola?